Hi, good afternoon, everyone, and thank you for tuning in to Smart Nation together today. So if you would like more info about our other tech-related talks, do check out the link that I'll be pasting in the chat below. So today's webinar will be on AI and robotics in healthcare, and it's co-organized together with NCS. So NCS is one of Asia-Pac's leading tech services firms, and they specialize in working with governments and communities and enterprises to advance communities through tech. So for those of you who might not be so familiar with NCS, they provide end-to-end digital solutions in cloud, platforms, and other tech services. So today we have with us Sunil, who is an AI researcher, and he's got 15 years of experience in developing and commercializing ML solutions. So, and his areas of interest are really in speech, NLP, IoT, and other areas as well. For Anne, she's leading the product incubations team at NCS, and she's previously an entrepreneur for 12 years in Asia. So today she will be telling us how ideas can be translated into commercial solutions. Yeah. So without further ado, I will pass over the time to Sunil, who will be sharing more about AI and robotics in healthcare.
Thank you, Michelle.
Yeah.
Shall I start the screen now?
Yes, you can. Go ahead.
All right. Okay. Are you able to see my screen?
Yep. Yep.
Great. So, yep, a warm good afternoon to everyone. From wherever you are tuning in, from your office or from cafes or from home. Thank you for taking time to listen to us. So my name is Sunil Sivadas. So I'll be initially presenting a little bit about how, a background of AI, how this whole thing started and what lies ahead, before handing over to Anne to focus on the healthcare part of it. So I have three tasks mainly. One is to kind of give you an essence of AI and get you excited about it, so that you may appreciate some of the exciting challenges and may even consider, if you are not already an AI technology, get into AI technology. The second thing is to keep you engaged and not letting you fall asleep. So that's the second goal. So I thought the best way to do it is to bring a little bit of Hollywood into the talk, so that I can keep you engaged and as well as teach you a little bit about the AI. So I started with this slide, which is the imitation game, and use it as my starting point to explain about AI, what is AI and how it affects our daily lives, and what lies ahead. So sit back, get your lunch and your favorite drink, and here we go. So first question, just to how many of you have watched the movie Imitation Game, and what is this movie about? You could answer it in the chat. Okay, so maybe yeah, I'll probably give you a bit of a background about this movie. So this movie is actually about Alan Turing. So Alan Turing was a British computer scientist who was working during the World War to crack the Enigma code. And this movie is about the life of Alan Turing. So why is this important? Because he kind of laid the groundwork of AI and the initial thinking about AI and how it can be used in our life. So I'll spend a little bit of time on how this whole thing began, and then I switch to the practical applications and some of the things that you encounter in the daily life. So this is the real Alan Turing, not the Benedict Cumberbatch. So he published a very seminal article in 1950 in this journal called Mind, asking this question: can machines think? So that was the one of the very first recorded statement about in a peer reviewed journal about can machines think. So he posed this question and framed this question in a way that what does it mean by thinking? So that's very difficult to answer, right? So he created this test called imitation game or a Turing test. So that is how this movie imitation game, the name came about. So assume you are one of the players in the game. You are sitting behind a bar, a kind of a wall, and you are interacting with two through two holes on other side of the wall. You cannot see who they are. There's a hole A and a hole B. Now the game is to kind of figure out which one of them is a human and which one of them is a computer. So that's basically the Turing test. So what it means is, like, if a computer can fool you into thinking that it's a human, then that's a sign of intelligence. That's how Turing phrased this question of, try to answer the question, can machines think? So now you can think of different applications that you encounter in your daily life, like chatbots. When you are interacting with them, they're trying to mimic being a human, right? So you can relate to this when you are interacting with a Siri or Amazon Alexa or Google Assistant or whatever. So that is the very first example. So now what can machines think is now stated as what will happen if a machine imitates human. So this is how the AI kind of the field started forming, and people started creating experiments and thinking about, can we actually make machines emulate humans? So another computer scientist, John Mccarthy, he was a computer scientist in Stanford. He was the one who actually coined the term artificial intelligence. This was about 1955, about 5 years after Alan Turing published his paper. I want to go a bit further back, about 100 years, which is somewhere in 1850s. In Spain, there was an artist, photographer, a doctor, bodybuilder, and scientist, and many things rolled into one. This person called Santiago Ramon. So he was considered as a father of modern neuroscience. And why is this important? Because a lot of things that we know about our own brain, he started drawing using pen or painstakingly on a paper with with whatever he sees through a microscope. There were no electron microscopes, so he was not able to see in magnified form what these nerves or neurons are. So he started kind of drawing this. So this kind of started because if you want to know how to emulate humans, you also want to know how the machine or how the brain works, right? So he was interested in knowing how the brain works, and when he's looking at the different cells, he was able to see these neurons. And then sometime about the same time, there were these two guys called McCullough and Pitts, who was also wondering how to create a model of the mind. So what they did was, so these guys are based in Boston, in MIT and Howard. So what they created was, for the first time, they created something called an artificial neuron, based on some of the things that they observed from other scientists who were working on trying to draw those neurons, and through the microscopes and through various other experiments, they created the first artificial neuron, which is a computer program that could mimic the way, a very simplistic way, a neuron, a real neuron works. So he said in his class, there are professors in the McCullough was a professor in MIT. For the first time in the history of science, we know how we know, which is essentially saying that we kind of trying to figure out how our brain works. So to kind of put this whole thing, all these things together in one slide. So there were these folks who were thinking, can machines think? Try to mimic the intelligent behavior. And there were folks like Santiago Ramon trying to figure out how brain works, which is about the perception, how we see, hear, all that, and cognition, or understanding of the world. And the other folks who are building the computational model of brain using software and hardware, that's the neural network, which is the foundation of the modern AI. So this is how it kind of all began. But it's been quite a ride since then. A lot of things changed. The understanding of AI changed. So a more modern approach of AI, as proposed by a Berkeley professor, Stuart Russell, and Peter Novick, an American computer scientist, is actually the AI is mostly concerned with the rational action. It's not so much about mimicking humans, because we all make irrational decisions, like, when you get emotional, right? So what the modern approach is more about, like, how an intelligent agent can take the best possible action in a situation using the data that is, like, available for it. So it's like a rational action, right? So let's see how this is used in some of our modern, like, that world and many other problems. So I want to take you to this example. So in 2002, Oakland Athletics baseball team. I know baseball is not a common, very popular sport here, but there is a link to it. So they built a team of undervalued talent by taking a sophisticated data-driven approach. So, in baseball, people, in football also, people buy stars. Like, people buy Ronaldo and Messi. Sometimes they buy people for their star value. But what Oakland Athletics team did was a bit different. So their manager, Billy Bean, tried to assemble a team with very limited budget using undervalued teams. So can anyone say, can anyone know what, tell me what this episode was about? There was actually a very famous movie, kind of like, explaining what went on behind the scenes. Can anyone put it in the chat? Okay, so in 2012 or 13, I think there was a movie. This movie came called Moneyball. So yeah, I told you I'll use a lot of Hollywood examples, right? So you go and watch this movie, and it's a very interesting one. If you don't enjoy baseball, it's fine, but just watch it for the fun of it, and try to kind of, like, stay on the part where he tries to put together a team of undervalued talent, or, like, underachievers from most people's perspective, and created an almost winning team. And what he did was he actually used methods from probability, statistics, and all that economics to put together this team. So that is one practical example of using rational action. Using AI for rational actions. Another one I want to show you is based on finance. So it's called quants, and there is this famous hedge fund called Renaissance. And what is the secret sauce that made this fund the best hedge fund in the industry? So let's see from the founder of this hedge fund company. Okay, why Medallion is the best hedge fund in the world. So it has outperformed, I think, consistently all the funds in, like, comparable funds. And here is Prof. James Simmons explaining.
Are these giant beasts of equations and algorithms, or are they simple things?
It's what's called machine learning. So you find things that are predictive. You might guess, oh, such and such should be predictive, might be predictive, and you test it out in the computer, and maybe it isn't, maybe it isn't.
What discipline of mathematics, or disciplines? Is it multidisciplinary, or are we talking?
It's mostly statistics. It's mostly statistics, and some probability theory.
Okay, so that was finance. Okay, now I have a quiz for you. So the question is, I'm pretty sure many of you watch Netflix, right? So when Netflix recommends a show, are you engaging with AI? Awesome. So I think almost all of you got it right. Okay, so no worries. So I'll show in the next slide, I think. All right. So let me move on. So true. It's actually true that when Netflix is recommending you something, it's actually using AI. So there is a story behind it. Netflix has been using this AI called recommendation engine for a while, and I'm pretty sure you are all familiar with it, because when you interact with a e-commerce site like like Amazon or Lazada or Shopee, they're all recommending you things. So in 2006, Netflix launched a competition, an open competition to everyone, where anyone who could beat their in-house recommendation engine will get a $1 million prize. So this ran from 2006 to 2009. So what essentially they were trying to do is they were asking people to come up with algorithms and methods that could beat their own recommendation, because they were doing quite well and it was not easy to beat their own system. So you can see why it is a $1 million prize, right? So that kind of created a kind of made the data scientist or the machine learning engineer role very glamorous. So there was a group of people who could actually beat the Netflix recommendation engine, and they won $1 million. So you could look it up. And so that was one example that every day when you're watching a movie, you are actually interacting with AI, or AI is influencing your behavior or habits. Here is another one. Next quest. Michelle. Thank you. So AI technology, and I'm pretty sure a lot of you know AVs, right? Autonomous vehicles. You may be hearing about it. So can AI technology independently drive a car at the level of a human driver? This is an interesting one. I see there are a lot of people who are not sure. Okay, so actually the answer is false. So the self-driving tech is not yet ready to reliably handle a variety of situations that human drivers encounter each day. So it can handle certain things in a very narrow context, but it is not ready to take over the role of a human. So this is something that, when you hear about many folks in the media talking about AI is ready to to create an autonomous vehicle, kind of critically evaluate, ask questions. What can it do or what it cannot do? So that's one example. But I want to show you some progress on what actually make the autonomous vehicle car a kind of closer to a reality. It is not there yet, but a crucial part of that is the computer vision. So I want to show you a bit of how the computer vision advanced over a period of years. So initially, the computer was able to detect an object on the screen and put a rectangular box around it, saying that this is a plant, this is a human, this is a refrigerator. By the way, what you're seeing on the screen is generated by a computer. Okay, and later it was able to detect the humans and its skeleton, body parts, and even very accurately put color on the pixels, not just a box, where in the image or the video does this person or the object exist. And this is one of the crucial underlying tech that enables autonomous vehicles or any robot that's navigating around you, because it needs to know exactly what it is seeing and where they are in the vision, right? So the computer vision has improved quite a bit over the last few years, and that is what is driving the surge in the AV tech. Okay, now I want to take you to something a bit more interesting and funny, but it also shows you the power of AI. Okay, listen to this. I'm pretty sure many of you have heard about it.
Have you ever seen a polar bear playing bass? Or a robot painted like a Picasso? Didn't think so. DALL-E 2 is a new AI system from OpenAI that can take simple text descriptions like a koala dunking a basketball and turn them into photorealistic images that have never existed before. DALL-E 2 can also realistically edit and retouch photos. Based on a simple natural language description, it can fill in or replace part of an image with AI-generated imagery that blends seamlessly with the original. It's called inpainting. In January 2021, OpenAI introduced DALL-E, a system that could generate images from text, like this avocado armchair. DALL-E 2 takes the technology even further with higher resolution, greater comprehension, and new capabilities, like inpainting. It can even start with an image as an input and create variations with different angles and styles. DALL-E was created by training a neural network on images and their text descriptions. Through deep learning, it not only understands individual objects, like koala bears and motorcycles, but learns from relationships between objects. And when you ask DALL-E for an image of a koala bear riding a motorcycle, it knows how to create that or anything else with a relationship to another object or action. The DALL-E research has 3 main outcomes. First, it can help people express themselves visually in ways they may not have been able to before. Second, an AI-generated image can tell us a lot about whether the system understands us or is just repeating what it's been taught. Third, DALL-E helps humans understand how AI systems see and understand our world. This is a critical part of developing AI that's useful and safe. The technology is constantly evolving, and DALL-E 2 has limitations. If it's taught with images that are incorrectly labeled, like a plane labeled car, and a user tries to generate a car, DALL-E may create a plane. It's like talking to a person who learned the wrong word for something. DALL-E can also be limited by gaps in its training. If you type baboon and DALL-E has learned what a baboon is through images and accurate labels, it will generate a lot of great baboons. But if you type howler monkey and it hasn't learned what a howler monkey is, DALL-E will give you its best idea of what it thinks it could be, like a howling monkey. What's exciting about the approach used to train DALL-E is that it can take what it learned from a variety of other labeled images and then apply it to a new image. Given a picture of a monkey, DALL-E can infer what it would look like doing something it's never done before, like paying its taxes while wearing a funny hat. DALL-E is an example of how imaginative humans and clever systems can work together to make new things, amplifying our creative potential.
So that's a great example of how a AI system or a machine learning system can kind of represent the world and create new images that only that exist in our own imagination. So what you saw there is a lot of examples where you could think of in your head, but you may need something like a Photoshop or some creativity tool to kind of draw it, right? But now what is happening is someone was just typing in a koala bear riding a motorcycle, and it was able to generate that image because it was able to create a representation of the world. The AI was able to have a representation of the world from which it was able to generate this image. So how does AI systems learn all this stuff? I'll give you a very simplified view of how things go under the hood. Okay, it's not very mathematical, but just want to give you an idea. So what is happening here is the machines process this information, all these images, text that it finds in the internet, into mathematical operations, because that's all machines are capable of, right? It can add, can multiply, can subtract, divide, all this stuff. So what it means is all these artificial neurons that I mentioned in the beginning, treat them as some kind of a black box for now, and map these words into an internal representation like this. Inside the computer, it's represented as some kind of things floating in the space. So when these things are created inside the computer memory, it should have some consistency. So words like man and woman relates to the gender, the king and the queen similarly, and they should be in a form that's very consistent. So it's like man is to woman, saying that it's kind of similar to king is queen. So similarly, for actions, things like the verbs should stay close and have some consistency when these objects are created inside the representations are created inside the computer. You should have a consistency across the tenses. So walking is to walked, should be have the same similarity as swimming is to swam. So this is the operation that maps once it kind of learns this way of representing, that's kind of the internal thing that DALL-E or any other AI system has. It's a very simplified view. So what do we get out of it? So which means we could create these kind of mathematical concepts, new data out of it. So very simply put, when DALL-E was trying to create a koala bear riding a motorcycle, it was trying to add a few things and subtract a few things, and and then voila, you get an image. Okay, so very similar to a human will do on the Photoshop, remove some stuff, add some stuff, blend it in, and but now an AI is creating it. So the way it does is it composes different concepts to create new stuff. So very similar, what we can learn by putting two shapes together to create a new shape. it can subtract this information and generate a new information. So that's essentially what DALL-E is doing. And to do that, it has to have this kind of internal representations. So now let's move on to, like, how does human brain look like internal? Okay, so brain has about 100 billion neurons, and also it means it has about 100 trillion synapses, means connections across different neurons. So where does the current AI algorithms stand with respect to the number of neurons or the size of or the amount of neurons in the human brain? So this is an example. Don't need to worry about memorizing all this stuff. But what it shows is, over the last 4 years, the number of neurons in the AI models have gone from a few millions to a few trillions. And that's basically that kind of like, the model, that the DALL-E system that you just saw, that was able to create this interesting representations of the world, has probably about a few trillion neurons inside. So that's the growth that kind of like, over the last 4 years, that enabled this tremendous advances in AI and applications. But there's a flip side to it. Although there are 100 trillion synapses and 100 billion neurons, the brain only consumes about 20 watts of power. Okay, so for the current AI systems, that's not the case. So all these AI models that is used in autonomous vehicles or the chatbots, they all consume a humongous amount of power or generate a lot of carbon emissions. So that is one of the concerns when it comes to AI. So a lot of companies are addressing this part, how to bring the power consumption, emissions, and all the negative impact on the environment. The other thing is bias, and that's a very important aspect too. That when we are interacting with AI, when you're interacting with the Netflix, or when you're interacting with a chatbot, the decision that you make is influenced by the prediction that the AI makes. So means if AI has a bias, you are influenced by it. So I want to give you the next quiz. Michelle, over to you to start the poll. So can AI accurately detect someone's emotion from a photo at the level of an adult human? True, false, don't know. I'm pretty sure that you have been, you may be using apps which captures your face, or you've seen systems, automatic systems, maybe that scans your face. And this is actually happening in the real world. People are looking at other, the faces and trying to judge, really judge what the person is thinking or feeling. So the answer is false. And it's very important that it is false, because there was a systematic review of scientific literature or technologies that claim that they can predict the emotion from the photo. And actually, a neuroscientist named Lisa Feldman found there is no reliable evidence that you can accurately predict someone's emotional state from this manner. There are so many things that goes on behind your your face or other inside your brain that finally manifests as emotion, and your face is is not the true representation sometimes. And that, again, culturally it may look different. So just by looking at a photo, it's not possible to predict someone's true emotion. And actually it has manifestations in real life when people claim that they can do it and make certain outcomes or predictions based on this emotion that will have a very detrimental effect. So when someone claims, please have this question in your mind. The other question is, what causes AI bias? Is it the data? Because all the AI systems are trained with a lot of data. Is it the algorithm? It's a neural network that goes inside, or both? Awesome. So most of you got it right. It's actually both. Although you may see some kind of school of thought or arguments that it's the data that's where the bias is, like, because when you collect data with a bias, that bias gets represented in the prediction, right? So that is true, but the algorithm also plays a part. Even if the data is unbiased, the algorithm can learn things a bit differently that causes the bias. So it's actually both. And this is very important also, because when we rely on AI systems that can influence our daily life, it's very important to know what are the biases and how it affects us. So this is actually a infographic from World Economic Forum, kind of trying to capture how AI learning, the bias in AI and machine learning can result in some form of discrimination. So as you know, we have a lot of data that is being generated, and that is used to train the models, and that's put into use, and then that predictions is used by people out there to arrive at decisions, right? So in the data, there could be bias. The bias could be coming from the sampling, which not equally sampled. Some factors are amplified. It could be age, it could be gender, it could be demographics. That results in the bias in the data. And then the bias also can result from, sorry, give me a second. The bias could also come from the deployment practice. So which means there are only certain people who have access to the way the AI can be deployed, right? Because it's not easy, it's still not a level playing field. And that's the power imbalance that can result in the misuse or the bias in the AI. So that is the design part of it. Then the third one is the application. So where all it gets used, for what all purpose, in CCTV cameras, for public safety, and how is the outcome being used? Is it for when you apply for healthcare? Is it actually improving or the overall well-being, or is it actually creating more digital divide or deeper divide among the people that results in more health inequality? Because the data and who can deploy it will determine this, right? So then the last one, of course, is who, when we apply it in our real life, whether it is a doctor or whether it is someone in a public safety official, where and how it gets applied, and what are the implications of that on the end user as a citizen. So if you look at it, there are many examples of AI, and then you can start thinking, how is it affecting me? So I just want to maybe give you a bit of it's not all gloom and doom. There are a lot of breakthrough applications in medicine, manufacturing, and other industrial fields that kind of improved our quality of life. But we call this narrow intelligence because they're all good in doing one thing very well, not the general intelligence like the way humans have. Like at the beginning of the talk, I spoke about can machines think, right? So that has now become more like a narrow AI where we can do very well in certain areas. So that is what currently that's driving AI, and people are getting slowly being aware of the biases and the other negative aspects, and trying to kind of adjust or put those regulations and guardrails in place. So I have one question. Next, it's a quiz again. Can AI technology analyze X-rays with equal or better accuracy than a resident level radiologist? True, false, don't know. And this is something that's actually currently you will either see or you will see pretty soon, this kind of applications. Great, I think most of it got it right. So it's actually true. So in a matter of seconds, a machine learning or AI algorithm can read chest X-rays for many different pathologies. And it can perform as well as a radiologist in most cases. This was what a study by the Stanford found. But the question that comes to people's mind as soon as they hear this kind of report is, will AI replace radiologists, right? because anytime you see a robot doing certain things, the first question that come to, or like, an AI doing certain things, the first question that comes to, will it replace something, right? A human. But that's the wrong question to ask. According to Dr. Curtis Langlotz, the right answer is the radiologists who use AI will replace radiologists who don't. So what it says is AI is going to be an assistant to humans to augment or amplify its capabilities and not replace, because that is how the AI is going to progress, like, help humanity progress. So there was this another important computer scientist called Licklider, who famously said was a psychologist and a computer scientist. He kind of like invented a lot of our human computer interaction, methods, how we interact with computer. So he said it is the destiny of computers to become interactive intellectual amplifiers, which means we will be all working with computers, just like, the things evolved from the calculator. People probably hardly use calculator now, because now I think everybody asks Alexa, hey Alexa, what is 1 + 1, right? You don't even type into a calculator. So that's basically how the AI is going to define its role. So I want to show you another example. So this is an example where AI helps a human to code, to write computer programs. All a human has to do is to write a textual description of what it wants to create. A computer program is generated automatically by the AI. So this is actually another interesting product from OpenAI called Codex, and it's actually also used in GitHub Copilot, where to start with something, you don't have to create the code from the scratch. Just type in plain text. So an example here is like, now plot the results, label both axes, and then it generates the JavaScript code. It's not going to be 100% accurate. There will be bugs, there will be security flaws, but it gives you a pretty good starting point. And as you can see that how it can increase the productivity of humans when it comes to writing the code, but you still need a human in the loop. So I want to give you another breakthrough example that kind of like, is going to have a big impact in our lives. So this is, I'm pretty sure you might have heard of this AlphaFold from DeepMind.
Inside every cell of your body, billions of tiny machines are hard at work. They carry oxygen in your blood, let your eyes detect light, and even make your muscles move. These machines are proteins, and they underpin every biological process in every living thing. Each protein has an intricate 3D shape that defines what it does and how it works. We know of over 200 million proteins and counting, but we only know the exact 3D shapes of a fraction of these. Unravel a protein, and you'll see it's like a string of beads made up of 20 different types of amino acids. Interactions between these amino acids make the protein fold, as it finds its shape out of almost limitless possibilities. For decades, a community of scientists have been working on a way to figure out a protein's shape, just from its string of amino acids. This is a major challenge in our understanding of biology. So we created an AI system to solve this problem called AlphaFold. It's trained on the sequences and structures of about 100,000 proteins, painstakingly mapped out by scientists around the world. Today, it can accurately predict a protein shape just from its sequence of amino acids. AlphaFold's predictions could enable progress in all sorts of areas. Imagine a future where we can understand diseases more quickly and develop drugs to fight them, or one where we could use enzymes to break down plastic waste, or even to capture carbon from the atmosphere, all with the help of proteins. There's a lot more work to be done, but unlocking the shapes of these building blocks could help scientists better understand the natural world, and perhaps expand our knowledge of life itself.
So you saw another application of AI, right, in medicine. So I have another question for you. Can AI understand cause and effect? Like, for example, if I heat water, then it'll boil. Good. It's a 50-50. Oh, it's a bit. Okay, so I see there is a bit of a ambiguity here. Like, it's almost like you're not sure. Actually, AI is not able to understand the cause and effect. Although it can spot these patterns that humans can't. For example, can't or cannot spot easily, like in an X-ray or in the proteins, it still can't explain what caused something. That's still like, if you ask a human something like, what caused that collision, a human is able to explain. A car was going in this direction, it jumped a red light, or like, it turned left when it was not supposed. All these can be done, but AI is not there yet that can explain this phenomenon of like, some of even things like when you heat water, it'll boil. It may learn from observation that every time you heat water, it may boil, but it can't explain, like, it just spot that pattern, but it doesn't mean that it knows what caused it. So it only captures the correlation between events, but not the causality. So that's very important to know. This is again something that AI is still not capable of. So it can learn the patterns, but it cannot explain the cause and effect. So next question, I'll move on to the next quiz. Artificial intelligence is capable of thinking for itself, independent of human beings. True, false, don't know. So you can think of it like, like a human. As a human, we all are able to set goals for ourselves, right? Or is AI? Is it possible for AI to do something like that? Actually, yeah, I think a lot of people got it right, but still there's a bit of an ambiguity. It's actually false. So currently, AI is not capable of thinking for itself. So this is some of the things, some of the controversial media coverings that you may be seeing in the newspapers recently about AI being sentient. Is it true? So computers are extremely good in narrow tasks, like, playing games, recognizing objects, or like, or finding those protein folding shapes, but they don't have, like, what is called autonomy, or like, ability to formulate their own questions. It cannot ask, hey, what am I going to do in 10 minutes? As humans, we are all capable of asking questions to, like, what are we going to do in 5 years time? AI at this moment cannot do this kind of, like, ruminations or questions. And this is very important, because a lot of questions, things about artificial general intelligence and computers becoming closer to human, all these are, what all these questions that I'm asking here as part of quiz are the gaps that computers cannot do at this moment. Okay, over to one more question. It's a bit practical, and I think I gave away the answer here. I shouldn't be asking Michelle, sorry. Maybe I'll just skip it. So AI technology, the question was more like AI technology be able to banks to spot credit card fraud. Because I picked this question because there's been a lot of, like, similar incidents happen, right? So actually it is true. The AI technology is capable of spotting frauds, and it's actually being used right now in many places. And it can generate this kind of patterns, can detect these patterns that are fraudulent and differentiate it from the genuine ones. And this is like, a good example of how AI is used in practical life for good. So yeah, so that's the broadly what I wanted to convey. And I took all these like, borrowed these questions from a very good source called America Needs AI Literacy Now, and I think it's a generally applicable to everyone in the world, not just America. So go have a look at this there are a lot more questions, very interesting questions out there. Have a look and you'll get to know a lot more about what AI can and what AI cannot, and that will, like, give you a sense of, like, ability to critically think when you see some reports in the media. So to conclude, let's go back to the first slide. So what was Turing after when he was trying to break the Enigma code, or when he formulated the question, can machines think? So he was actually trying to reverse engineer the Enigma code, much the same way he thought, like, how AI should be built, by reverse engineering the code of human intelligence, and in a rational manner, because all he was given was a lot of code from the Enigma machine, and he had to use machines to figure out, reverse engineer what this code is about, right? So a lot of practical applications of AI is very much like this. So that's in a gist. I want to convey, like, how it all started and where we are and what's next, and hand it over to Anne for the next section. Thanks, everyone. And Michelle, I assume the Q&A is at the end, right?
Yep, the Q&A will be at the end.
Okay.
So yes.
Thanks, everyone. Over to you, Anne.
Thank you very much, Sunil. So let me, it's my turn, share my screen with you.
And as Anne is putting out the slides, just want to thank Sunil again for the very interesting presentation on AI. And yeah, I think Anne will then be sharing about what NCS, some of the applications that NCS is creating in the area of healthcare. So Sunil, he's an AI researcher himself. He has 15 years of experience in machine learning. So he heads the Next Gen Tech Center in NCS, and that's where he he develops and commercializes a lot of those solutions. And now we will be hearing from Anne. She was an entrepreneur, and she heads the product incubations team at NCS. So she'll be sharing with you some of the robotics and AI applications currently in NCS. So over to you, Anne.
Thank you very much. Do you all see my screen? Is that all right?
Yep.
Yeah.
Anne.
Thank you very much. So just now, Sunil explained what is AI and how the models that are created train to perform tasks like what humans do. And actually, as he explained earlier on, you can see them in action when you watch or when you search for any content online. And the same capability can be used in healthcare. And this is what we're going to explore here, because at NCS, we have developed a few solutions to relieve nurses in hospital. So nowadays, when you go to the doctors, there are already many areas where you can where AI is used by doctors to assist them with medical imaging, for example. This is one typical example. Another typical example will be a diagnosis or helping diagnosing let's say, illnesses using the various combination of symptoms. But when it comes to physically help the patient, the doctors, or even the patient in a ward in hospital, that was a lot more challenging because it required a combination of many different capabilities to be embarked into robots or devices. And it's only with the recent acceleration of the computing capabilities and power that it became possible to actually embed AI in those kind of devices. So typically in Singapore, Smart Nation encouraged hospitals to work together at solving many of the hospital challenges, because typically the aging of the population on one end and the shrinking of the healthcare population really created a huge crunch in the ability of the healthcare people in delivering their day-to-day work efficiently. So this is why we were tasked with the necessity to redesign healthcare in hospital with key priorities such as patient safety first, the patient experience, because it shouldn't be at the patient's detriment, relieve nurses from all mundane and administrative tasks. It should be easy to use, and with one overall goal, which was to improve the nursing overall productivity with anything that was non-nursing tasks. So typically, this is how we came up with, so the key problem statements in the first place when it comes to patient safety was to focus onto the patient fall risk, which is one major issue in hospital, because 2 to 15% of patients will experience a fall while staying into a hospital, while 75% of these occurrence will lead to complication. So this is a major burden, not only for the patient, but also for the hospital that has to be taken care of. So we'll see later on what are the solution we came up with. And of course, the solution could not be to even further burden the patient, the nurses in their daily tasks. Another key aspects of nurses' improved capability or improved productivity was to reduce the time they spend at, for example, taking vital signs and synchronizing, entering those data into the systems. Typically, this action only eats up nearly half of their time, where it is a very automated and very simple, very mundane task. And since they only have limited time to spend with each patient, it is unfortunately often at the detriment of the quality or the quality time they could spend with that patient. So this is one key task that they wanted to improve. The other one being the item deliveries. Believe it or not, but 20% of a nurse's time is spent at delivering items like food, blanket, water, samples, documents, and so on. Do you need to be a nurse to deliver things? Obviously not. And do we want to have non-caregivers in hospital? Neither do we, because in hospital is already very crowded and it increases the risk of propagation of epidemic or contamination. So a good way to cover this kind of need was to consider robots. And this is how we came up, or our engineering department, robotic engineering department, gave birth to Florence. Florence is a robotic nurse assistant. So it aims at helping the nurse in the ward. So it automates vital signs taking and the synchronization with the patient file, while it also can deliver food items, but also medication safely to the patient, while the nurse is helping the patient with other tasks in the ward. So for now, this robot, Florence, is being trialed in Alexandra Hospital, and we see that it already frees up to 20% of nurses' time, which is exactly what we were expecting. Let's watch this short video, 2 minutes, to show you how it works.
Hello everyone. Let me introduce you to Florence, our robotic nurse assistant. Florence is a result of collaboration of Alexandra Hospital and NCS Healthcare Innovation to automate tasks such as items delivery, vital signs measurement, and synchronization of patients' records. This will free healthcare practitioners from performing time-consuming tasks so that they can focus more on patient engagement and patient care. Here is Florence to assist me in my daily tasks. Florence would perform the highly repetitive tasks that do not require my nursing skills. I have just programmed Florence to check and record vital signs of all the patients in the ward. I would also like Florence to do another repetitive task of snacks delivery. So here I am, loading it with the snacks to be delivered to the patient.
Visitors, please move away from the bedside. I will be approaching you. Hi, my name is Florence. I am here to take your vital sign measurement. Kindly look at the camera. Please scan your wrist now. From 0 to 10, please tell me your pain score. Please keep still and breathe normally. The measurement will take up to 1 minute. Please insert your finger and relax. Measurement has completed. Please remove your finger. All measurement completed.
The vitals of the patients recorded are then automatically synced with the patient's records for future use. This automation procedure saves up to 17% of nurses' time. In case the vital signs are worrying, the nurses would be notified.
Hope you like my service. I will make a move now. Hi, my name is Florence. I am here to deliver the requested item.
With Florence as my assistant, I am able to focus on providing quality care for my patients.
So you saw earlier on, typically this robot that looks very simplistic, but what is quite interesting with Florence is you saw that it looks very cute, very simple, and you may wonder, why did we make something so toyish to some aspect? It's also because I don't know if you all experience this strange feeling when you face a very resembling human robot where you don't know exactly what's real, what's not. And this is exactly what happened with the initial ideas, the initial format of the robots. The patients were kind of scared with the robots that looked too human. So it's only after many iterations that we came up with a very simple, friendly design that patients feel very comfortable with. Do you have any idea of the number of computation or AI tools that are embedded into this robot? It is autonomous navigation, face recognition, object recognition, movement detection, language understanding, speaking, in all together with all the capabilities of vital signs taking and data synchronization that do not require any AI. Another use case was the patient safety. Typically, our team's Sunil's team came up with a fall prevention solution where typically computer vision capabilities, so typically the ability to identify and to understand the meaning of some movements, were embedded into tiny cameras that you can see on the screen that are deployed into a ward. In this case, it's actually in Changi General Hospital, in order to identify when patients are exiting their bed, or even prevent that by anticipating by a series of analysis, the moment where a patient may exit its bed. And typically these cameras are also able to dispatch a message, a personalized message to the patient, asking him or her to wait patiently for help from or assistance from the nurses. This solution aims at reducing the number of incidents by 80%, while improving the nurses' overall productivity by 17% without burdening them with false alarm. Let's watch this other very short video, less than 2 minutes, to illustrate this use case.
At NCS, we have developed a fall detection solution using video analytics on an edge camera. With this system, caregivers are immediately alerted when a patient or an elderly falls. Immediate incident detection and alert reporting to the caregiver triggers prompt rescue. This low latency minimizes the patient's suffering, distress, and risk of further injury. These edge devices respect the patient's privacy by auto-masking their faces and even blurring their contours. Machine learning further improves the solution by preventing incidents from occurring. The device computes the probability of a certain event, such as the fall of a patient. An alert is then triggered by the detection of certain postures, angles, or waves generated by the patient's movements. Upon detecting a series of movements leading to a probable fall, the device will play a personalized message instructing the patient to wait for help while alerting the caregiver. This grants time for the caregiver to reach the patient to prevent an incident. To get more information about 5G MEC video analytics, please scan the QR code.
So you see, these are a couple of examples of how we have embedded AI capabilities in various devices that are currently trialed in hospitals, so Alexandra Hospital and Chingy General Hospital, for the purpose of improving patients' life, improving nurses' overall productivity, without at any point of time compromising on the patient's safety or the patient's well-being, on the contrary. So yeah, these are, I hope that you found those examples reassuring and interesting. Feel free to ask any question in the chat. We'll do our best to answer. I give you back the screen.
Thanks, Anne. So I think in the meantime, I'm just going to flesh out our feedback slide. So as we're going through the questions and answers, appreciate if you could also help us to fill in the survey on the feedback. So just give me a moment. Okay. Right. Okay, let's get to the questions. So, Sunil, I think there was one very important question on misdiagnosis. So I think maybe we could go straight to that. I mean, I have my view, so perhaps I could start first, or would you like to start first?
Go ahead. Michelle, please
yeah,
go ahead.
I acknowledge that this is because AI is such a new field. There are legal and ethical frameworks that we first have to put in place to ensure safe development and usage of AI. So, Gerald, in answer to your question, I think in October of last year, the Ministry of Health, High Health Sciences Authority, and also IHIS, which develops a lot of our healthcare systems, they put together a set of guidelines on how AI can be safely used in healthcare. And in that guidelines, there were a few key principles that were covered, which I think it's very important for us to take note of. And one of them was actually the concept of responsibility, which is that while the developers developing the AI are responsible for ensuring that the computer algorithms are sound, the decision to use the AI and the decision to accept the clinical outcomes of that AI still lies on the healthcare provider. So there's that element of responsibility, and the guidelines are such that the responsibility still lies with the human using the AI. Yeah. So that's my take on it. And of course, apart from responsibility, there are other things that we need to be mindful of when using AI. And that also includes the idea of transparency, which is that patients must be aware that the solution is AI-based. And secondly, the idea of explainability, which is that the solutions and the diagnosis has to be explainable to the person. Yeah, so that's my view. And Sunil, maybe you can jump in at this point.
Yeah, thanks, Misha. Yeah, I think it's a very important question. Because when your life depends on the outcome of the prediction by an AI, right? I mean, it's everyone has a right to know. So during the talk, I explained that AI's role is to amplify humans' capabilities, and so which means there should always be a human in the loop that kind of makes the decision. It's not the AI that's going to make the final decision. So that is one way to kind of safeguard, or rather for someone to kind of critically evaluate what the AI predicted or recommended before applying that decision in real world. So what is happening here is actually it is helping humans to arrive at a decision quicker, much faster, and also consider many more possibilities. That is what actually AI is helping. So that is the positive side of it. And it's true that when AI makes a mistake, how to catch it. So there are certain, when the AI algorithms are being developed, like Michelle mentioned, there are internal frameworks and regulations being designed. So IMDA has a framework for testing the AI algorithms for AI ethics and fairness. I think he's the one that I think Michelle, you mentioned probably is also a part of that larger framework that IMDA, or maybe it's a separate one, but I know IMDA has an AI and ethics and fairness framework that it's creating, and that algorithms and people who create the AI tech can actually evaluate the different factors that will influence the outcome through this framework. Hope that answers your question.
Yeah, thanks for that, Sunil. Yeah, so, and I think that leads back to I think you had a point earlier on, right? Like the question is not about whether AI will replace humans, but it's basically that humans who are able to use AI will be able to reap the advantages. Okay, related to that, I think we have a question on Florence. So maybe if Anne could take that. And I think the question is also a very important one, which is, if Florence is able to understand non-English languages at the moment. Yeah.
Yeah, so that is actually one very key capability that has been developed specifically by Sunil, actually, and Sunil's team, which is a hyperlocal language understanding. So typically this, the module that has been embedded in Florence is understand Singlish, not only English, but Singlish, actually, hypercolloquial English. And it is currently being trained on other Asian languages, with this particularity of understanding, so speaking other languages is one, but also the ability of understanding English spoken with Asian accent, because there are plenty of speech recognition tools available in the market, but they do understand proper English. But whenever they have accents like mine or Sunil, that becomes less accurate. And this is what Sunil's team has been developing.
I'm just curious, and have you had any feedback from patients who maybe don't speak English, or they speak in Chinese or dialect? Yeah, would you have experienced any feedback on Florence in the course of your work? Yeah.
So overall, the feedback from the patients are excellent in a sense that they like interacting with the robot. It is true that at first, for those elderly patients who do not speak English very fluently, the initial reaction was a bit surprised. But we're also using on the screen various designs to engage with the patient. So beyond the language capability, we're able to convey the information that is expected, or the action that is expected from the patient. And the patient reaction is excellent. And we also, so the research team also conducted surveys, interviews with the patient to measure their adoption, their satisfaction, and overall they're happy with it, extremely happy with this. It kind of relieves the stress of being in hospital, kind of distract them from this anxious moments, let's say, and overall the adoption is excellent.
That's great to hear. And also, I think it's an iterative process. The more that Florence, I think, interacts with more and more patients, I think the better she would get at interacting with them. Yeah, that's what I'm thinking.
This is what we hope, yeah. But there is still a lot of things to do, actually, a lot of improvement to bring. We're not there yet completely, but we're on a very good path.
Great. Yes, and I think we had an interesting question also on human touch. Let me take a look at the question. Yes, I think it was a question about, oh dear, I think it was a question about, whether the intent of AI is really to channel away resources from people who are able to self-help and focus on people who maybe need a little more help. Wondering, Sonia and Anne, what are your perspectives on that? Yeah.
That could be seen that way. That could also be seen like offering the. So for those patients who actually could do with self-help, why not? But overall, the idea is not to replace the nurse, but rather to get those tasks being conducted by these robotic assistants while the nurse is engaging with the patient, or to have a conversation regarding the well-being, regarding things that will not be or cannot be covered by the machine. Typically, it's a human touch. So while the machine is taking care of the vital signs, for example, the nurse will be changing a dressing or changing a pouch or something like that, and engaging with a conversation with the patient rather than, taking a temperature and entering data. So I don't think it aims at channeling the resources away from the self-help or from the but more channeling the resources on tasks that are caregiving rather than admin or delivery or very mundane that has nothing to do with healthcare.
Thanks, Anne, for that. Yeah, and I think to add on to that, it also frees up the nurses' time to really have more time, to engage, with the patients on a one-to-one basis. Yeah, and because less time is spent on these administrative tasks, more time is allocated for the tasks that can only be done by a human, like exactly what you mentioned, is to show empathy to the patients and ask them about their well-being. Yeah, so thank you for that. Let's see what other questions we have. I think, Sunil, there was a question on DALL-E 2, which is whether it's accessible for testing online. Yeah,
it is. I think currently on an invite-only basis, not invite, but people can apply for it, and I think OpenAI kind of gives access after evaluating the request. The one primary reason is they also have concerns about how this tech is going to be used, right? Because it's a very powerful tech, and people can create very realistic images very easily now. So they're also evaluating the request, why you need access. That's one part. Then of course, it's a very expensive tech. So they don't want to kind of give it away for trivial purposes. But people can apply for access, and then I think they provide some credits and access based on the request.
Yeah. Thanks, Sunil, for that. Let me see whether we have any other questions. Oh, we have one interesting question on the difference between data analytics and AI. Yeah, so I'm quite interested in that as well. So maybe Sunil, you could explain it to us in 3 sentences or something. Yeah.
Yeah. Okay. So AI is a catch-all phrase. Okay. So although it started as what I started at the beginning, can machines think, was the profound question that Turing came up with. Later, the AI became, like I said, in the modern view of AI, is actually a more like rational actions. So anything and everything that can help you take a rational decision is considered as AI. So it became a catch-all phrase, and the tools can involve probability, statistics, machine learning. very advanced tech like DALL-E, all these now kind of like, got folded under AI. Although it's true that there are very subdivisions and specialities that exist under it, like, probability and statistics is a specialty on its own, but people just use AI now everywhere. So I think the example is like, the Medallion hedge fund interview with Simmons, right? Professor Simmons, he talks about it's mostly statistics, but people use under the hood a lot of very advanced tech nowadays, like neural networks are kind of like, basic building blocks. So it's very difficult to say what actually people use nowadays. But yeah, originally they were two separate parts. Statistics and probability was on one side, and AI was predominantly about thinking human intelligence, but now it's all kind of folded into one broad area called AI. And it's also a bit of a marketing gimmick many times, even though there is not much of a AI under the hood, people will still love to say, oh yeah, we are applying AI.
So would it be right to say that data analytics is maybe a subset of AI? Would you frame it that way?
Okay.
Yeah.
What we actually call AI nowadays is actually, and most of it is machine learning, which is another a subfield of AI. So AI involves a bit more than machine learning sometimes.
Yeah.
So, but it's like that. Data analytics is actually a part of the machine learning where you need to know. I mean, it's analyzing the data and then trying to build an intelligent machine that can predict something, right? So that is the machine learning part, and data analytics is under machine learning. So it is a subfield that way. And then to do data analytics, we need to know probability, statistics, and all that. So it kind of like, goes a bit like, deeper and deeper like that. If you go try to analyze what is that exact skill that you need.
So, I mean, would you say that, in order to pursue a career in AI, you would need a background in data analytics? Just for the point of discussion.
There are many ways to approach a career in AI. So AI, right? I mean, it is not just the machine learning and algorithms. To put AI into a practical use, I would say maybe majority or maybe more than 75% of it is actually software engineering. So what is most important to be in AI, if you want to be a technologist, is to have a programming skill. Like, that's the most important thing. So AI again has like, multiple things, right? Multiple parts. There's a tech, there is a business side of AI, there are ethical sides of AI. So just like any product development, it has different parts. So if I'm talking here only about the technology side, which means need to be interested and excited about programming. Of course, excited about things like, how things work, like, and then see whether I can solve something similar using AI, and which will require some element of understanding of probability, statistics, linear algebra that will help. But nowadays, there are ways to even treat it as a black box and be very good in software engineering and create useful systems. That's also possible. Of course, there are certain downsides to it. You really don't know what this black box is doing sometimes. So that's a downside. So that is the technology side. Then, of course, there is a product like, strategy, product engineering, ethics, all that becomes like, other essential ingredients to build a successful AI business or an AI product.
It does sound like a very exciting field. And I would like to segue then into the next question, which is whether there are any courses related to AI and healthcare in Singapore. So I do know that there are SkillsFuture courses available. So I'll just do a quick search and I'll paste it in the link, but I'm not sure if maybe NCS would have any courses or training that to open up for public, to learn more about AI.
No, actually, NCS does not. We do have an academy that is more for our engineers, software developers, and we are using, whenever it comes to train external resources, we would recommend using those that are available. There are indeed quite a few available provided by SkillsFuture. We know that NTU, NUS are also providing classes. There are many classes also available on solutions like Coursera and the like. There are many things online, many things in universities, but NCS do not sell training for the public. No.
Yeah, I can I think AISG, some of you may be familiar about AISG. So AISG provides this AI courses for pretty much anybody who wants to make a transition to AI. That is one great resource to look for.
So meanwhile, I think we still have about 7 minutes. And so I would like to request for those who are still with us, if you could just answer. I mean, I would like to thank our NCS colleagues for really providing this very informative sharing on AI and robotics and healthcare. And for those of you who are, interested in a career in the tech industry, do help us to maybe answer the short poll that is by the side. We still have maybe 7 minutes, so please help us to answer that poll. And yeah, I'm not sure if Alice, would you, for people who are interested in the tech program, would you have any email address for people to write in?
Sure. For the tech program, maybe Alice, can you help?
Yeah, sure. So yeah, thanks everyone. I think it's really a good session, and thanks for your enthusiastic questions. So for checking on career opportunities with NCS, you can always follow us on LinkedIn. Just search for NCS Group, and our logo is 2 blue slash. And then you can also visit our website, ncs.co, and you can search under the career page. I believe when you register for this webinar, for some of you who have indicated your email addresses with Smart Nation, we'll also have your data captured. Yeah, so if there are, but the best channels to stay tuned for the career opportunities would be our website and our LinkedIn.
Thanks for that, Alice. Okay, I think we have answered most of the questions actually. Yeah, so I will just maybe leave this room open for people to continue answering the poll that we have by the side. Meanwhile, if you have any questions, do continue to type it in the Q&A box, and we still have 5 minutes with our speakers, Anne and Sunil. So while they are here, do take the opportunity to ask them any questions about AI that you might have. And sorry, I realized there was a question about Internet of Things, and I happen to know that Sunil also does research into Internet of Things. And I'm not sure, would a person would like to elaborate a bit more on the question, like what exactly about Internet of Things you are interested in? Yeah. So meanwhile, Sunil, just curious, out of curiosity, what other things are keeping you occupied, besides AI? What other areas of research are you focusing on right now?
Oh yeah, AI itself is quite a lot to cover. I think I'd like I mentioned, it's a wide area. So under AI itself, there are various subfields, like the RNA, the Florence nurse assistant. So that's a good example of an embodied AI where AI has a shape, right? Instead of just being a computer program, it has to actually interact physically with the surroundings and environments. So there are a lot of challenges in that, how to train a robot. So that's something that my team looks at. It's not easy to put a robot in a real world and let it learn from everything, because that's very expensive. So how to simulate conditions to learn from those simulations? How can a robot learn? That's something that that my team is looking into. So that will involve understanding the objects, which is like the computer vision, interacting with people through language, which is so all that becomes part of the simulation. So that's an interesting area going forward. So why I brought it up is I'm pretty sure a lot of you are kind of hearing this term metaverse a lot lately, right? So it means different things to different people. So there are many versions of metaverse, right? So the way Facebook or Meta sees it is it's a personal space. But for industrial applications, it means a bit different. It means we can actually use this metaverse like a digital twin to learn something, to automatically learn for something for AI, or kind of help increase the productivity, figure out if there is something goes wrong. So that is the industrial version of metaverse. So that is something that's pretty exciting and interesting, and something that we are looking into, like the example I gave you, the simulations, how to use simulations to learn AI, to teach AI agents. That's something, yeah, interesting for us, and I think you have that as one of the topic in next hack, right? Maybe this is a good platform to kind of like to say good about that.
Yes, you're right. Actually, even though it's a bit in advance, NCS is launching again this year its innovation challenge. It's an open innovation challenge that is open to not to individuals but to startups. So if there are people in the audience who are running startups, we are more than welcome to join. We will launch it officially on the 9th of September. And the three themes are sustainability, so tech for sustainability, energy savings, and decarbonization. Hyper automation. What does it mean, hyper automation? It's augmented or AI augmented automation. And at last but not least, metaverse for business. So what's in for business? What can we do with metaverse for businesses? Yeah, so let's stay tuned. Actually, we're launching that on the 9th of September.
It sounds really exciting. Yeah. Okay. I think we have just 1 minute left. So maybe one last question for Sunil. Yeah, earlier on you mentioned that, your team was also, I think Anne mentioned that your team is responsible for, teaching Florence how to speak Singlish. Yeah. So I'm just wondering what was the process for that, because that sounds really interesting. Like, did you feed her with a lot of Singlish, phrases and stuff? Yeah.
Yeah. So good. Yeah. So like I mentioned in the whole design of AI, right? I mean, there's a lot of data involved, algorithms involved, and that's how you build the AI. So yes, a lot of data is required to teach a machine how to understand, or rather transcribe, a speech in a particular accent. So that is why you see that some of the American or the products from the Western countries like Amazon, Alexa, or Google, or Siri doesn't work very well for the Asian accents. So that's because in here, every other person speaks with a different accent in Singapore, right? Almost. So that makes it really challenging for machines or AI agents taught with American or Western native English accents to understand. I mean, even humans face a challenge. I mean, I'm not saying that not only AI, even as humans, we also have challenges, in understanding people with different accents, right? So that's a common problem. Even we need to get used to some accents before we can understand it. So the same applies to machines as well. So yes, in general, you need to teach the machine with a lot of data.
Yes. Yeah. So I think with that, we've come to the end of the webinar. So thank you once again, Anne, Alice, and Sunil for your time. And thank you, NCS, for showing us, what are some of the exciting new advances in AI and robotics for healthcare. So